Good morning. Today let's continue our discussion regarding the fourth model, that is tree. Okay, what is tree? Okay, how we are going to store the trees and what are the properties of the tree? All things we discussed in the previous class. Okay, now we continue our discussion regarding the binary trees. Okay, see, binary trees are the trees where each node which consists of maximum of 2 number of nodes, which maximum of 2 nodes it can holds, that is binary tree. See, there we having the 3 types of traversing. How we are going to traverse the tree, in the sense here we are having 3 types of traversing, that is pre-order, post-order and in-order. Okay, these are the 3 types of traversing the tree. See, last class we discussed these things. Okay, how it is internally run in the code, how it is recursively call the function, we are going to discuss today. Okay, see, last class we discussed in the pre-order. Pre means previously. Okay, node visited first, later on it moves to the left and right. Okay, it is of the form node left right. Okay, node left right. Pre means previously. It comes, node comes first. Okay, when node executed or node encounters, it have to be print the value of the info of the node. And post order, okay, left, right and node, left, right, node, that is the syntax of, that is the traversing method of post order. Last one is in order. Okay, in order is left first, in order in between node will comes and right. Okay, these are the 3 things. Okay, 3 things discussed in the previous class. Now what do you mean by recursion? Okay, recursion means a function call itself. Okay, the function call itself repeatedly till some certain condition satisfied. That is called as recursion. We discussed these things in the first year itself in the PCD subject. Okay, recursion are the functions, the function which call itself. Okay, the function repeatedly call itself till execution. Okay, till some certain conditions satisfied. Okay, that is called as recursion. See, now I having the function that is pre-order traversing here. Okay, pre-order traversing functions are here. Okay, see how it works. Let's see how it works. Let's see. See, it going to call. Okay, what is the root? Root is a pointer which holds. Okay, root is a pointer which holds the first node information. Okay, first node information. Okay, first node of any tree is the root node. See, in the last class itself we discussed how the pre-order traversing are carried out. Okay, say a way to traverse. I going to give an hint of that one. See, which order you are traversing, that is pre-order. Pre-order in sense where we having node left right. Okay, right node left right in each at each and every node. Node left right, node left right. Okay, node left right, node left right. Okay, node left right, everywhere I written that one, node left right. Okay, see here iterately, continuously the function call itself. Okay, see here pre-order traversing is there. See, the function which going to call itself called as recursion. The function which going to call itself are called recursion. Recursion function. See here, pre-order functions calls twice. Pre-order functions calls twice. Okay, when pre-order function calls, how the functions executed with the help of this tree. With the help of this tree, I want to explain. Okay, here this is level 0. Here we are having level 1. Here it having level 2. Okay, level of the function. Okay, level of the tree. Okay, now from the main function, when pre-order function calls, when the pre-order function calls, a root value will be passed from the main function to the sub function, that is pre-order function. Okay, root information is there. Okay, here root is a. Okay, if root is a, means first you have to check that one when you are performing any traversing operations. Check that one either root is empty or not. Okay, if my root node, root is a pointer here. Okay, root itself empty in the sense, null in the sense we don't have any nodes in the tree to traverse. Okay, for that reasons you have to check either the root is null or not. Okay, in case root is null, check. Okay, it's going to return. Okay, it's going to return back. Okay, it's going to return back. It not entered to the looping itself. Okay, iteration process is not going to carry it out. See, if root is not null, if root is not null, it entered to the first pre-order traversing says that one, print node first. See, listen carefully. I am going to do the your recursion procedure in this tree. Recursion procedure. See, first loop. Okay. See, be careful. See how it works. I am going to tell that one. See, in the initially it going to encounter node. Okay. Keep one thing in mind. When node encounters, okay, it going to print that information. Okay, print that info. Okay, see that one here. This is node, this is left, this is right. Okay, when node encounters, it going to prints. Okay, node encounters, it going to prints the first information, that is A. That is the information A. Okay, now through the recursion functions, it going to calls left. Through the recursion function, it going to calls left encounters. When the function calls root of left instance, the root of left, okay, this becomes the root now. This becomes the root now in the recursion procedure. See, now it going to calls once again. Okay, checking that one. That root is null. No, it enters. It prints that information. Okay, it prints that information. Okay, n is printed. Okay, see, in this recursion function, this function calls the B functions. Okay, see, till A function is not wind out, till A function, the recursion function calls here is not wind out, it is entered to the B. Now B encounters and print the B here. Okay, don't confuse. Initially A is the root. When left function calls, B is the root now. Now the root information is B printed. Okay, this function is not wind out because it's still at the left node. Okay, it's still having the left node. The recursion functions calls once again. Move to the D. Now D is the root. When checking that one, D is null. No, it's going to print the information of the D. That is D get printed. Okay, now node is completed. It's checking of left is null, close it, right is null, close it. Okay, it goes back. This looping function, okay, this iteration is over. Okay, this recursion iteration is over. It goes back. Now the right node. Okay, see, previously this function calls up to here, it executed, not right. Now it start calling the right function. Calling the right function. When the right function calls, okay, in the time B is the head, it goes to the E. Now E is the head. Okay, when E function calls, once again root of it. Okay, E is the node here. When the controls here, when you are having a control here, it is going to encounter N, means N in the sense node. Okay, it print the E value. Once again, it is having a left, no return. It having a right, no return. Okay, I hope it is easiest procedure. Okay, now this recursion function wind out. Okay, this function also wind out. It goes back to here. Initially A is the root. Later on, when it calls left, B is the root. When call left, D is the root. Okay, when it is over, right, when it call right, E is the root. Goes back, and now it come back to the original condition. Okay, initial condition. Now node is encounter, node loop is over, left loop is over, right loop is remaining. It calls right. Now the function calls C. Okay, now node is C. It prints C there. Okay, N completed. Okay, N procedure is completed. We having left and right. Okay, when N printed, C printed. Now left, it calls recursively, it calls left. It goes to the F. Okay, now F is the node. It going to prints. Okay, don't have left and right. When you having left node is null and right node is null, it returns. It not going to do any operations. It goes back. Okay, it going to calls once again C. Okay, C, left is over. Okay, it's remaining with right. It calls the C. Okay, it calls G. When call G, okay, scratch that one. Okay, now it calls the G function. G is the node there. it's going to print G, it don't have left, it don't have right. Okay, it goes back and it turn out this pre-order procedure, and outcome of this one is A, B, D, C, F, G. Okay, this is a recursively a function call itself. Recursively this function call itself and give up this. Okay, for particular given tree, this will be the output. Okay, this will be the output. Okay, now see, let's do the same operations for the in order too. Okay, how the in order functions are carried out. See, I consider the same tree. Okay, wherever the node left right are there, I am going to call it as with left right node function. Okay, see, initially it going to, okay, for the same tree we having the, for the same tree we having the function. Okay, see, what's in order? In order says left node right. In order says left node right. Okay, I return left node right everywhere. See, okay, this is one of the method. Okay, you may follow other methods too to traverse, but if you if you write up like this and trace the things in sense, you don't miss in any condition. You don't miss it in any condition. For that reasons, this is one of the easiest method. Follow this one. It may take on the time. Okay, initially it may take on the time. Once you are practice and get into this, okay, how the traversing are carried out, okay, it become very easier. Now in the in order traversing, okay, once again it is a recursively call. Okay, recursively call the in order function twice here. Recursively calls the in order function twice here, one to the left, one to the right. It's going to traverse to the left once, it's going to traverse the right once. In between, it's going to print the node information. Okay, now see, be careful. What are the things it's going to bring from the main function? Root. Okay, what the root consists of? What the root consists of? In sense, root consists of the information of A. Why? Because this is the tree they built. This is the tree they built. Okay, now when root is not null, it continues. Okay, see, if root is null, you have to be return that one. Okay, don't do any operations, go out. Okay, don't do any operations, go out. Just like it going to returns. Otherwise, it enters. Okay, now it going to cause in order of root of left. Okay, see, root of left is called. For that reason, I put wrong mark to the L. Okay, means it traverses to the L. Node encounters no. For that reasons, printing operations are not carried out. Okay, this loop calls, okay, this iteratively calls, the recursively calls B function. Now B is the root. Now, okay, now it going to calls L is there, yes, it, okay, L is there, left is there, yes, okay. Once again the function called to the left. Now D, okay, left is there, no. Node is there, yes. Okay, when node encounters, it print the root of info. Here, when the control comes here, D is the root. It going to print D. Okay, it going to print D. This is in order. This is pre-order. This is for in order. Okay, this is for in order. It going to print D first. Okay, now nodes is printed. Checking that one either right is there, no, it returns. Okay, recursively D go back to the N. Why? Because D node it over. Okay, now it checking that one. B left recursion is over. Okay, control C is here. Okay, it going to print N. N in the sense node. Okay, what it having? It having the B. We are having the B there. Okay, B over. Next, it having the right function. It going to check that one. Either right function is there. Yes. It calls once again, right function calls in sense, controls goes back to here and call once again all the operations. Okay, right function is there, yes, it calls the right function, it moves to the E is the node now. Okay, E is the root now. Okay, now check that one. E having the left, no. E having the node, yes, print that one. Okay, here root of info is E. Now right is there, no, close it. Okay, now E is printed, the recursion procedure, this E node is encountered is closed. Okay, B node is over, then it goes back to the A. A node is encountered, no, till it will be running there. Okay, A only is running up to the here. Now A will be get printed. Okay, now it calls recursively function, it calls right. Okay, when it calls right, it moves to the C, it moves to the C. Now checking that one, C having the left, okay, now when the control is here, C is the node, C is the root node, it calls left, move to the F, okay, left is there, no, node is there, yes, it going to prints. Now checking that one, right is there, no, goes back. Now C is the root, okay, left recursion is over, node is there, yes, it going to prints C, now it calls the recursively calls right function, right subtree, okay, the control is at G, now G is the root node, checking that one, left is there, no, node is there, yes, okay, right is there, yeah, no, okay. In this way, recursively a function call itself and traverse the given tree. Okay. This is pre-order, this is in order. Okay. I will explain the post order. Post order is simple. Okay. See, only thing is that one, I want to modified here only post order. See, the printf statement comes at later region. Okay, this is the function for recursive function for post order traversing. Okay, see, in the post order traversing, once again it brings with the root, see, now see what are the changes you supposed to made here. Okay, in order you have taken the left node right, in the post order you have to be taken left right lastly node, left right node, okay, left right node, okay, for all the nodes you are supposed to write the things. Okay, now the post order traversing is here. See, it brings the information of the root node is A. Okay, A is null in sense nothing is there to traverse, see, it calls the function post order initially. Okay, printing function is at last. For that reason, the function calls it and left things get executed. When this encounters, it goes back. Control goes back to from initial itself. Okay, these two are remaining at the A itself. When A is node, these two statements are not encountered. It goes back and making that B is the node. Okay, B is the root node. Okay, now checking that one, B is null. No, it going to calls post order. Okay. It going to post order of left link is there, yes, left link is there, it goes here. Now once again the control goes back to here. Okay, two times it calls one function. Okay, D is the root node, left is there, no, when it is not there in sense, it's going to check for right is there, no, and later on it going to print the resultant. Okay, what is the result of that one is D. Okay, this is in order. Okay, this is pre-order. Okay, now we are writing the post order. Traversing. Okay, it encounters D and print the value of D. Okay, function calls once again. Okay, now left right node is over. It calls once again B. Okay, B is the root node now. Okay, this procedure is recursively it goes back to the B. Now checking that one right node is there, yes, it traverses there, close it, okay, traverse there. Okay, check that one, now is the root node, checking that one, left node is there, no, right node is there, no, node is there, yes, print E, it going to print E, now, okay, left right node is over, okay, it goes back, left right is over, node is not encountered so far. Now it encounters node and print B, okay, or okay, goes back to the recursion function what it calls initially from A. Okay, there right is there, okay, left is over, right is there, called the function once again. It traverses to the right and C is the root node now. Okay, recursively the function calls once again. Okay, C is the root node now. Okay, C. Okay, C having the left, yes, calls. Okay, once again, F is the root node now. Okay, left having no, right having no, node is there, yes, it's going to print F. It's going to print F. Okay, it goes back, which it goes to calls. Okay, left is over, right is there, yes, it's going to calls right function. Okay, right, okay, now G is the root node, left is there, no, right is there, no, node is there, yes, it's going to print G. Okay, when a printing procedure is over, it goes back. Okay, it goes back, either left recursion is over, yes, right recursion is over, yes, node is there, it's going to print C. Okay, node is over. Now it goes back, left is over, right is over, and left out with node, that is A. Okay, in this way. Okay, the functions called recursively, that is called as recursion. Okay, recursively, when you traversing these recursion functions are executed for performing the in order, pre-order, post-order traversing. Okay, this is the binary tree traversing methods. Okay, say I conclude. Okay, binary tree are the trees which maximum having 2 children. Each node consists of maximum of 2 children. Okay, traversing are 3 methods: pre-order, post-order and in order. Okay, in the pre-order, node comes first. Okay, it is going to print the node function and travels to left and travels to right. In the post-order, okay, it's going to traverse to the left first, travels to the right next, and it's going to print the node information. And the in order, traverse to the left, print the node information, traverse to the right. Okay, see how the recursion function calls. Okay, see you have to be having a tree there. See, right, the left, right node everywhere. When it encounters, put crash of that one and move to the next level. And this is the in order, this is the pre-order, and this is the post-order traversing of the given tree. Okay, thank you. This is a simple method. Follow this one. Thank you. Next video, we are going to see how this binary tree are stored inside the memory. Binary tree. Welcome back. See, so far, okay, last thing we are going to discuss how we are going to traverse recursively, that is in binary tree traversal, that is in order, pre-order and post-order traversing. Okay, now we are going to continue our discussion regarding binary tree representation. How you going to represent your binary tree? Okay, inside the memory, how you going to represent the binary tree? In the sense, there we having the 2 methods. First one is array representation. Second one is linked list representation. Array in the sense, that is static method of representation. Linked list is an dynamic method of representation. Okay, see, usually regularly you are going to use linked list representation only in our discussion much more, but this is one of the method. There we are having the array representation. Okay, what the linked list representations is consist of? Okay, so you know that one. Okay, double linked list is used to represent the each and every nodes of the tree. Okay, why? Because double linked list having the left link also and right link also. Tree is also having the 2 links. Okay, see, each double linked list, okay, a single root will be splitted into the 3 parts, that is, okay, each root will consist of left link, info field and right link. 3 things are there at the each node. Okay, each node, it may be the root node or any node it may be, it should consist of 3 links. Okay, 3 components, that is, okay, in the binary tree a node consists of 3 information, that is left link, info field and right link. Left link, info field and right link. Okay, see, consider this one as the left, okay, node information. Okay, no, this is the root. Okay, it consists of info field and it consists of left link. Okay, where it consists the address of left subtree. This right link consists of address of right subtree. Okay, it consists of address of right subtree. See, this linked list representation will be diametrically represent in this fashion for our convenience. Not an issue if you represent like this also, not an issue, but our convenience we want to show, okay, write our tree in this fashion. See, each node will consist of info field, okay, info maybe 100, assume that one, here having the 100 is the node information, okay, it having the left link, it consists of the address of the left subtree, and it having the right tree, so right link which having the address of right subtree, okay. See, this is the one of the method of, okay, binary tree representation, that is, okay, each node will be represented by using the linked, okay, double linked list, okay, which consists of info field, right link and left link. See, for our convenience we are going to write your trees in this fashion, okay, where info is having the 100, okay, right link consists of right subtree address and left link consists of right, left tree address, okay. Now second one is array representation, okay, this is dynamic, okay, this is dynamic. If anytime usually you want to follow the okay, dynamic representation only. Why? Because if the tree grows, okay, linked list will be allow you to continue, but in the array representation, that is static one, see, it depends on the, okay, representation will depends on the how many nodes are there, okay. See, this is my tree, assume A, B, C, D, E, F and G. This is my tree having the level 2, okay, 0th level 1 node, first level 2 nodes and level 2 having the 4 nodes there, okay. See how it represents, always when it becomes the array, see, always 0th node holds the address of root node, okay, 0th node, okay, holds the address of root node. Now see how many values are there, 1 2 3 4 5 6 7, see, it going to give us the number for that, okay. 0th node always holds the address of root, okay, 0th node, first node, second node, third node, 4th, 5th and 6th, okay. These are the 6 nodes are there in the tree. How it represents, always 0th nodes, checking that one, if the 0th node is null, in sense tree is empty, like that you are going to come to a conclusion. See, 0th node, first node, second node, third node, 4th, 5th and 6th, okay. See, 0th node holds the first value A, first node B, C, D, E, F and G, okay. In this way your given array is represented in the form of array, okay, where always 0th node, okay, 0th value will holds the address of the root, okay. Here root have to be mentioned separately, okay. If in the linked list, if root is null, tree is empty, if root is null, tree is empty. Here the A of 0, okay, 0th location of the array is null, in the sense we come to a conclusion that one tree is empty, okay. In case having one more option, okay, maybe, okay, you having partially filled with the tree, okay, A, B, C, D, I don't have F there, I only having the G, okay, I having the G. How you going to represent these things in the array form, okay. See, 0th location, first, second, third, 4th, okay, 5th should be okay, may be present, okay, should be present, but in this tree you don't have the 5th location. How you going to represent that one, in sense? See, simple, okay, it going to follow the same array, 0th position, first, second, third, 4th, 5th and 6th, okay. See, there, see, okay, 0th A, root of that one, 1 B, 2 C, 3 D, 4th E, okay. Here F is missing, okay, it leave that space empty, and continue with the remaining component, okay. This is the array representation. If that, okay, node may consist of, okay, may present, but, okay, some condition, some situation, that tree may not consist of that node F, okay. One more example, on the time leave that space empty, statically the size is fixed. If when it is encounter, the 5th location is empty, in the sense you have to leave that 5th location as empty, okay. It continues like that, Okay, see this is the binary tree representation. See, we are having two methods of representing the binary tree, that is array representation and linked list representation. Okay, see, array representation is static. Why? Because if you want to include one more node instance, you have to be reconstruct this array once again. Okay, that is for that reason it is static one. Dynamic is okay, linked list representation. Okay, you can increase your trees to the any extent. Okay, see here root node. Okay, sorry. Here the linked list, double linked list is used for representation of the representation. Left node gives the information of the left subtree. Right link gives the information of the right subtree. Info holds the information of the root tree. See here tree is there. Array representation is in the fashion. Okay, it continuously gives the stores the information according to the number. See, if a of first array location is 0 instance, root is tree is empty. Okay, in case is in between a node is missing instance, we are going to leave that space empty. Okay, this is our representation of binary tree. Okay, see, thank you. Okay, welcome. See, last concept of your today's discussion, that is level order representation. Okay, level order representation. Okay, see how these types of representations are carried out in the tree, for the binary tree. See, a binary tree is given. Okay, we are having the levels, level 0, level 1, level 2, level 3. Okay, maybe think of that one, A having the two children, maybe B having one, but D having the two children once again at the next level. See, how in these types we are having a tree, assume, okay, by considering that one example, how you going to represent this binary tree, okay, in the level order representation. See, simple, not a issue. See how many levels are there, you want to mention, okay, level 0, level 1 and level 2 continuously. See, first how to represent that one instance. See, first level, okay, what is the first level, what are the values are there, you want to represent from left to right. See, A is the only value, okay, at the 0th level. When you come to the first level, from left to right, what are the values are there, continuously stores, okay. What are the values are there, B and C. Level 1 we are having the value B and C, values we are having B and C, okay. Now see, next at the level 2, which are the values are there, D, E, F, these are the values are there, you want to store continuously, see D, E, F, okay, D, E, F, okay, level 2 we having the values D, E, F. Next level 3 we having G, H, I, okay, means left to right is supposed to go with G, H, I, okay, this is the, okay, in this way we want to represent your level order representation, okay. See how to write that one instance. See, writing the level, okay, from 0 to n, how many levels are there. See, from each level, okay, represent the value, start storing the value from left to right, okay. See here 0th level we are having only value A, at level 1 we are having 2 values that B and C, and level 2 we are having 3 values that is left to right, okay, whichever node it may be, D, E, F, that D, E, F will come into picture here, and level 3 we are having G, H, I, okay, G, H, I are the values of the level 3, okay. This is the level order representation of the tree, binary tree, okay. See, let's come to a conclusion. What are the topics we discussed today? Okay, first one, see, what do you mean by binary tree? A tree which consists of maximum of 2 number of children or 2 number of nodes as a children, okay. See, then we are having, see the traversing, that is in order traversing in the sense left, node, right. Recursively we seen pre-order, node, left, right, post order, left, right, node, we seen that one. Next, how we are going to represent our binary tree, okay, we are having 2 methods, that is linked list representation and array representation, okay. Linked list representation is the dynamic method and array representation is the static method. We see in those things, okay. How to represent those one, you see that one. Last one is level order representation. See, we are going to define all the levels here, see, on the basis of each and every levels, level 0, level 1, level 2, level 3, it goes on, okay. See, it starts storing the values from left to right towards each and every level, okay. Level 0 having 1 value, level 1 having 2 values, that is B and C, level 2 having 3 D, E, F, and level 3 also having 3 values, that is G, H, I. Left to right is supposed to write all the siblings what you want to fold, okay. This, okay, these are the topics we discussed today, okay. Thank you. Okay, next class we are going to see the concept called as threaded binary tree. Okay, initially simple. See, instead of saving, okay, storing the null value, okay, we stores, okay, what value is supposed to come next, okay, that is threaded binary tree. We discussed in the next class. Thank you.